Question 5. Now I thought this is quite complicated really. The thing to take on board is that the scale is 1 to 50. So the real life garden is 50 times bigger than the drawing, or in other words the drawing is 50 times smaller. 50 times smaller than the actual garden. So we've got to each of these dimensions that were given for the real garden, we have to divide by 50 to work out its size. So let's, for example, take the circular space with the diameter of 2.5 meters. Well, 2.5 meters is 250 centimeters. Dividing that by 50, we realize that's got to be 5 centimeters in diameter. Remember, diameter means all the way across the whole of the circle, not the radius halfway, all the way across. Similarly, the distances from the house and from the fence you have to divide by 50. So 0.5 meters, which is 50 centimeters, divide by 50, that's 1 centimeter, and the distance from the house, which is 150 centimeters, divide that by 50, that's 3 centimeters. Now you can't really see it on this version here, but if you actually look at this on paper, 2 squares represents 1 centimeter. So we're saying 2 squares represents 1 centimeter. So each of these, to convert from the number of centimeters to the number of squares we're going to be using, we just need to double each of these. So my circle has to be 10 squares across, and it has to be more than 6 squares from the house. 1, 2, 3, 4, 5, 6. So above that green line. And then more than 2 squares away from both the path and from the garden fence. Okay, that's the dark black line all the way around. So basically it's got to be inside this area here, because clearly it can't fit in this area here. So as long as you've got it being 10 squares across and somewhere inside this area here, you're going to get your full marks. Now for part B, this is our raised flower bed, and this is the shape from above, so that gives us the cross-sectional area, and then we're going to go and pop some earth in it to a depth of 0.2 meters. So we're going to have to end up working out what the volume of soil is going to be in here. Now to do that, we need to work out this area, this cross-sectional area of this T-shape, and then multiply that by the depth of the soil. So step 1, we need to work out the area of this shape here. Now I've broken this area down into 2 rectangles, this blue rectangle and this pink rectangle. This blue rectangle is 2.5 meters across, because we're doubling that 1.25, and 0.9 meters deep. So 0.9 times 2.5 gives us an area of this blue rectangle of 2.25 meters. This pink rectangle here has got a height of 2.3 meters, a depth, a width of twice what 0.375 meters is, which is 0.75 meters. So to work out the area of this pink rectangle, 2.3 times 0.75, giving us 1.725. So our total cross-sectional area, we add this blue area and this pink area, we get 3.975 meters. Now that's that area. So if we then go and put the soil 0.2 meters deep, the volume of soil we're going to need is 3.975 times our 0.2, which is 0.795 meters cubed, or if you like, 795 litres. Now each bag, which is 900 litres, each bag contains 900 litres, which dividing by 1,000 is 0.9 meters cubed. So we need soil to the volume of 0.795, and a single bag is 0.9. So yes, we do have enough. Alternatively, you might have been comparing litres. You'd be comparing 795 litres to 900 litres. So yes, Kai is correct, and 1 bag is enough, because 1 bag covers 0.795 meters. No, it doesn't. 1 bag covers 0.9 meters cubed, and we only need 0.795 meters cubed. So Kai is correct.